Welcome back to Wildcat Academy. Today we'll be simplifying rational expressions. So a rational expression is a quotient of two polynomials. So sometimes there's only a constant in the numerator, but there will always be a polynomial function in the denominator. Our steps to simplify a rational expression will be to completely factor the numerator and completely factor the denominator. Then we will cancel common factors and we will simplify and rewrite the remaining expression. So in example 1, we have y minus 6 in the numerator, and we have y squared plus 2y minus 48 in the denominator. So the numerator is already completely factored. It's a linear binomial, no GCFs or no common factors of the two terms. And in the denominator, that's a trinomial. So we will rewrite the trinomial as the product of two binomial factors, and we will factor this out into y and y, and our factors of 48 that add to be positive 2 will be positive 8 and negative 6. If you're curious about how to factor that trinomial, there'll be a link right up here to the right that you can click on. It'll take you to a video to discover how to factor that trinomial. Once we have this completely factored, we can now identify common factors in the numerator and denominator. So we have a y minus 6 and a y minus 6, and we will cancel those in a one-to-one fashion. And what is actually happening here is y minus 6 divided by y minus 6 is 1. So while we say cancel, what actually is happening is we're dividing those to give us a quotient of 1. So now we will rewrite our rational expression as 1 over y plus 8. Now, the second part of our problem says state any excluded values of the expression. And what this is referencing is division by 0. So anything that will cause the denominator to be 0 will be an excluded value. So these are just going to be the roots of this polynomial y squared plus 2y minus 48. And our excluded values is y cannot be equal to negative 8 and y cannot be equal to positive 6. As we look at number 2, we can see that in the numerator there is a greatest common factor of 3 that we'll need to factor out. So when we factor out the 3, you just divide each term by 3 and we'll get x squared minus x minus 20. And as I said, I would go ahead and completely factor that numerator one more step. 3 times x minus 5 and then plus 4. You can also do that over to the side. You can do it one step above and then the next step here. Just a matter of your notation and your form you would like to factor these. In the denominator, we have x squared minus 16. Well, this is the difference of two perfect squares. So we'll take the square root of both terms, x and x. Square root of 16 is 4 and 4. One is positive, one is negative. And then we have a completely factored expression. We will then cancel in a one-to-one fashion any common factors that we have. Then we can rewrite our polynomial as 3 times x minus 5 over x minus 4. We want to list out our values that are excluded. We have an excluded value of negative 4 and positive 4. We have to go back to our original completely factored form before we canceled to list out our excluded values. Just because an excluded value was canceled does not mean that the value can be inserted, because we could not insert that into the original expression. In example 3, we are once again asked to simplify and state any excluded values of the expression. So we will factor out the numerator and then we will factor out the denominator completely. So let's go ahead and take a look at the numerator. Looks like we have a greatest common factor of 4x. This gives us 4x squared minus 1. And I'm going to go ahead and continue out that polynomial until it's completely factored. 4x, and then I'm going to factor out the second binomial, that is the difference of two squares once again. That'll be 2x plus 1 and 2x minus 1. And then we'll go back and pick up the denominator. And then I'm going to factor it out. I'm going to factor out any GCFs. Looks like we have an 8x squared. And that will give us 2x minus 1. And then we're just going to rewrite that as it does not, it only factors in one step. Or it does factor in one step, I should say. Alright, so now we have the completely factored form. You can go ahead and list out your excluded values right here if you want to go ahead and do that. We get x equals 0, and looks like 1/2 as the excluded values. And now we want to cancel in a one-to-one fashion. So go ahead and cancel out the 2x minus 1 and the 2x minus 1. The whole factor must cancel. You can't just factor the 2x and the 2x. So be careful. They have to match completely. And because remember, we're not actually canceling so much as we are dividing to get 1. And then we will divide 4 and 8. And we will get 1 over 2. We will cancel one of the x's here, divide one of them away, and we'll get x to the first power on the bottom. Then we'll rewrite all of our terms that are left. We'll end up with 1 times 2x plus 1 divided by 2x, oops, just divided by 2x. On example 4, same method that we were using before on examples 1, 2, and 3. A little bit more complicated factoring that's going to go on in example 4. I wanted to show some of the more advanced methods of factoring that we encounter. In the numerator, that is a degree 4, but it's still in quadratic form, so we will factor that out. And once again, there's some links right up here, and there'll be some links in the video description that will take you to methods of factoring. So when it factors into x squared, and 6 and 1, both of them will be negative. This will factor one more time because this first binomial is a difference of squares. So that factors into x plus 1 and x minus 1, and then x squared minus 6. The denominator, that has 4 terms. So we'll have to use factoring by grouping. So I'm going to take the first 2 terms and group those together, and then I will take the second 2 terms and I will group those together. And I will factor out a GCF. So I'm going to factor out x squared of the first 2, and that gives me x minus 1. And I'm going to factor out a negative 6 out of the second 2 terms, and that gives me x minus 1 as well. And then see how we have the parentheses in both terms, or the same thing in parentheses in both groupings. So we can rewrite that as x minus 1, and then we'll put the coefficients in the other parenthesis. So that gives us x squared minus 6 and x minus 1. From there, we'll just match up our common terms. We will divide those to be 1, x squared minus 6 and x squared minus 6, or they cancel. And then we'll have x minus 1 and x minus 1 that also divide to be 1. And then we're left with a single term. X plus 1 is our simplified answer. Let's write that over to the side so it's a little bit easier to see. Write that as x plus 1. Our excluded values, we have to go back to our original problem. We'll have an excluded value of x is equal to positive 1. But we'll also have, when we solve this out here, plus or minus the square root of 6. Are values that we cannot plug into our expression because they'd cause division by 0. We can check that. You can see we can plug in 1 here. 1 minus 1 is 0. Square root of 6 squared is 6. 6 minus 6 is 0. The same thing would occur if we plugged in this negative square root of 6. If you found this video helpful, hit the like button. Subscribe to the channel so you catch the next video that we release from Wildcat Academy. And if you have a question about how to simplify rational expressions, leave a comment down below. See you next time.